In this video, we're going to look at the dot product of two vectors. Multiplying vectors is quite a different thing from multiplying scalars or multiplying a vector by a scalar. There are different types of multiplying, and the two most common of which are the dot product and the cross product. So I'll write that over here, dot product and the cross product. Okay, so we're going to start with the dot product for this lesson. The dot product of two vectors is defined as u dot v is equal to the magnitude of u times the magnitude of v cos theta. Okay, and you'll see right here, well, this right there is a scalar quantity. That's also a scalar quantity. And what I mean by scalar quantity, that means it's not a vector quantity. It doesn't have direction. It's just magnitude. And cos theta is going to return a ratio, and a ratio doesn't have direction as well. So this is a scalar as well. So we've got three scalars multiplied together. So the dot product produces a scalar quantity. Last thing I'm going to do is I'm going to label this, and I'm going to call this the geometric definition. And the reason why I'm calling this the geometric definition is because I have the dot product here, and I have this defined in terms of the magnitudes of the vectors times the cos of the angle in between them. So the result of the dot product, as I said, is a scalar quantity, so it's also called the scalar product. The dot product is the magnitude of the projection of u onto the v-axis multiplied by the magnitude of v. So it's the projection of u onto v. So what I mean by that is if this was a 90-degree angle right there, so it's the projection of u onto v and then multiplied by the magnitude of v. So let's do some geometry here. Cos theta is equal to adjacent over hypotenuse. So another way we can say this is hypotenuse times cos theta is equal to adjacent in a right angle triangle. Well, if we look at a right angle triangle right here, the hypotenuse is the magnitude of u. Cos theta, theta being the angle between the two vectors, and it is equal to the adjacent, right? And the adjacent is the projection of u onto v. Okay, first example. Find the dot product of u and v, where the magnitude of u is 7, the magnitude of v is 12, and the angle between them is 60 degrees. So literally this right here, the dot product of u and v is going to be our definition, which is u magnitude of u times magnitude of v times cos of theta. Right there, these brackets are not necessary. So then let's just sub in our values. U is 7, V is 12, cos 60, and the answer there is 42. The work done on an object is the product of component of the force exerted in the direction of motion multiplied by the object's displacement. Okay, so that's a lot of words. What we mean right that is work is equal to the magnitude of force times the magnitude of the direction cos theta, the angle between the vector of the force and the vector of the displacement. Okay, so if a box is pushed 10 meters to the right by a force of 200 newtons 30 degrees down from the right, how much work is done on the object? Well, we'll start this with a diagram. Okay, so there's my box, and over here I've got the magnitude of the displacement is 10 meters, okay? And then this is the magnitude of the force, and that's 200 newtons. And I know that the angle between them is 30 degrees. So I'm just going to apply this formula right here. So work is equal to 200 newtons times 10 meters times cos of the angle in between them, which is 30 degrees. Okay, so work is going to be 2,000 Newton meters times, and the cos of 30 degrees, if I use my special triangles, that's root 3 over 2. So then this is approximately equal to 1,732 Newton meters. Let's now look at several properties of the dot product. Well, the dot product is commutative, and when something is commutative, that means that the order of the operation doesn't really matter. So A dot B is the same thing as B dot A. If two vectors are perpendicular, their dot product is 0. Okay, so if I have a vector B right here, and it's perpendicular to vector A, I'll just say that that's perpendicular, okay, then A dot B is equal to the magnitude of A times the magnitude of B, and then cos, and the angle between these two vectors is 90 degrees. Well, I know that if the cos of 90 degrees, that's equal to 0, and zero product property, if anything is multiplied by 0, then the result is 0. Okay, so for two perpendicular vectors, the dot product between them is 0. Okay, for any vector A, well, if we take a vector A and we take the dot product of the same vector, A, well, that's equal to the magnitude of A times, again, the magnitude of A, cos, and the angle between two identical vectors is 0 degrees. Well, that's just going to be magnitude of A squared, and cos of 0 is just 1, so we just get A squared. For any number k, A dot KB is equal to K A dot product B is equal to K A dot product B. Okay, so it doesn't matter for the location of the K. It can be applied to the B, to the A, or it can be applied to the dot product of the two vectors. The dot product is also distributive. So what I mean by that is A dot B plus C, well, we can distribute that and say A dot B plus A dot C. And if I have A plus B dot product C plus D, then that's going to be just distributed A dot C plus A dot D plus B dot C plus B dot D. Okay, so that wraps up the properties of the dot product. Let's look at the dot product of algebraic vectors. So this is going to be my algebraic definition. I'll put that over here, even though it says it kind of above there. Algebraic definition. So if I have two vectors given these coordinates a1, a2, a3 for vector A, and vector B is b1, b2, b3, we can see that when we take the dot product of them, what we do is we are going to look at them in terms of their components, right? So a1 times the unit vector in the x direction, a2 times the unit vector in the y direction, and a3 times the unit vector in the z direction. Same thing with b. And now I just get the following. a1, b1 plus a2, b2 plus a3, b3. And as you can see, because this is all scalar multiplication, again, this is a scalar quantity. All right. Okay, so for this example right here, it says, given A is equal to 1, 3, negative 4, and B is equal to 2, 3, 1, find A dot B and the angle between them. All right, so let's start with my definition here. This is going to be a combination of both my algebraic definition and my geometric definition. So magnitude of A times magnitude of B, and then cos, sorry guys, right there, cos of the angle between them. Okay, so what I'll do here is I'll start with my algebraic definition. So I'll do this to the left right here. A dot B is equal to 1, 3, negative 4 dot 2, 3, 1. And if I look at my definition here, I'm just multiplying the same, the scalars of the x components, the scalars of the y components, and the scalars of the z components. Okay, and I sum them all up. Okay, so this is just going to be, let's get back over here, 1 times 2 plus 3 times 3 plus, and I'll say negative 4 times 1. Okay, so that dot product there is 7. But I also have the geometric definition right here. And for the geometric definition, I need to find the magnitude of A and the magnitude of B. So let's find the magnitude of A and the magnitude of B. I've already found the dot product. The dot product is 7. So let's find the magnitude of A. Well, the magnitude of A is defined as 1 squared plus 3 squared plus negative 4 squared, and then we take the square root. Magnitude of A is equal to the square root of 26. Okay, let's go ahead and find the magnitude of B. Magnitude of B is 2 squared plus 3 squared plus 1 squared, and then we take the square root of all that. Okay, so that's going to be 4 plus 9 plus 1. That's going to be square root of 14. Okay, so what I can do now is to find theta, the angle between them, I can combine the dot product and these magnitudes and then solve for theta. So A dot B, I already know, is 7. And then the magnitude of A is root 26. The magnitude of B is root 14. And then I have cos theta. So to isolate for theta, I'm going to bring everything over here. Okay. And then I'll have cos theta. And then to get theta by itself, I can just say, well, therefore, theta is equal to inverse cosine of 7 over root 26, root 14, and theta is equal to 68.5 degrees. Okay, so that's the dot product work right there, and the homework is listed below. Thanks for watching.